Hi guys. So I'm here to talk about scaling multi-tenant applications using the Django ORM and Postgres. I'm just repeating the title again. So before I get started, a quick intro about myself. So I'm Sai Srirampur and you can call me Sai. I'm an early engineer at citusdata, and the reason I joined Citus is to make it so that developers never have to worry about scaling their database. I'm also the creator of Django Multi-Tenant. So Django Multi-Tenant is a Django library which lets you build multi-tenant applications using Django and Postgres. And this talk would talk about that particular library. I have a couple of Twitter handles. Feel free to go ahead and tweet the talk. So before I get started, I would really thank the PyCon Canada organizing committee for giving me this opportunity to speak at the conference, and I'm really happy and excited to be in Toronto. So I'm here to talk about my favorite things. So let's chat about ping pong. Oh wait, it's not about ping pong, but rather the other favorite things, which are number one, Python and Django, which is my favorite framework to build web applications. Number two, Postgres, which is my favorite database. And all these in the context of scaling multi-tenant applications, which is the primary focus of this talk. So the reason I chose Postgres as my database of choice is because it is number one, open source, and number two, it has a very rich SQL environment. You have features like CTEs, window functions, full text search. You have very rich data types like JSON-B. You also have the ability to create extensions, custom extensions like HLL for count distinct approximations, Citus for like distributed capabilities, and then it also has a very rich geospatial story because it has the Postgres extension. So that is the reason I chose Postgres as the database of my choice. So today's talk is going to primarily focus on three main agenda items. The first is I'll talk about various architectures which are used to build multi-tenant apps, and then see which of them is the most scalable approach. From there, we'll see how to implement that approach or that architecture using the Django framework on Postgres, and that's where the Django multi-tenant library would kick in, and I'll talk about like how the library works and how it can be used in a production setup. And then last but not the least, we'll take a step higher and see how do we build infinitely scalable multi-tenant apps with distributed Postgres. So this is where like I'll talk some about Citus. So before I get started, curious on how many of you know what a multi-tenant app is? A quick raise of hands. Okay, that's quite some, but still I'll take a dig at it. So whenever I think of a multi-tenant app, the analogy which comes to my mind is an apartment complex in which you have multiple tenants, and each tenant has their own requirements. Say they have their own thermostat setting or have an internal different design, etc., etc. So the main characteristics of a multi-tenant app is it has multiple customers, and those customers can be termed as tenants. And number two, each tenant deals with its own data. So it's all restricted to that particular tenant. So most of the SaaS apps, most of the SaaS B2B apps can be considered as multi-tenant. A couple of examples which come to my mind are Shopify and Salesforce. So using Shopify, you yourself can go ahead and create stores, and there are multiple such stores, and each store deals with its own data. So Shopify is a classic example of a multi-tenant application. So you might be wondering, why is it important to think of scaling a multi-tenant application? So as a B2B SaaS company, you start off with, say, a couple of customers, then your customer base grows to tens, then it grows to hundreds, and then you are at a stage that you have thousands of customers and you have newer ones getting onboarded. At that stage, you want to make sure that your app is robust and stable enough so that it doesn't fall apart and it handles that scale. Hence, it is pretty important to think of building scalable apps right from the beginning. So let's get started. As I said before, we'll touch upon like various architectures of building multi-tenant apps, and we'll see which is the most scalable one, and then we'll see how to implement that in Django. So that would be like the flow. So the first approach which you could think of is one database per tenant. In this approach, you would have a single tenant residing in its own database. So you might be thinking what a database is. So I would define a database as, at a very high level, as an organized collection of interrelated data. Note that multiple databases don't share resources. So they don't share username and password, it's all separate. They don't share the connection set, they don't share memory resources, etc. So it's all isolated and it's restricted to each database. So this architecture would look something like this, in which you have multiple databases and each database would contain only a single tenant. So the tenant onboarding would look something like this, in which you, as and when a new tenant signs up, you basically create a new database, and then you migrate all your models to that particular database with, via the Django ORM command, the migrate command. And once these two steps are done, you have some app logic, which basically routes your APIs to the right database based on the tenant in action. So this is how, at a very high level, it looks. So what are the pros and cons with this approach? So the first advantage is you can start quickly, because you have a couple of customers, you create a couple of databases, and then you have the same app logic across both the databases and do the routing as necessary. So it's easy to start. The second is it has a strong isolation story, because finally, as I described before, this architecture is a shared nothing architecture. Hence, each customer is isolated from the other in a very clear fashion. And that translates to a stronger compliance story as well. So these are the advantages. But then coming to cons, the cons are mostly related to scalability, that as your tenant base grows and you have say hundreds or thousands of tenants, it is super critical for you to manage your resources across these hundreds of databases, because it's a shared nothing architecture. For that, you would probably hire a DBA to manage the resources. The second is maintaining consistency. For example, you wanted to create an index across all databases. You need to make sure that that index propagates to all the databases and then only commit the operation. The third is longer running migrations, because as the number of databases grow, you need to apply all your models. Say you have hundreds of models across all those databases. Hence, if you want to run a migration suite or a test suite, it takes longer to run. Last but not the least is, as the number of databases in a single Postgres server increases, performance tends to degrade. The reason is because the number of tables would increase, the catalog tables would grow large, hence your performance also would suffer. This is something which we have seen very commonly with our customers. This is the first approach. The second approach is a similar approach, but then you would have a single schema per tenant. So what is a schema? So a schema is a logical namespace that holds a set of tables. The difference between a schema and a database is you have multiple schemas as a part of a single database. Hence, multiple schemas share resources. So they have the same username and password, which is for the database. They share the same set of connections. They also have the same memory resources. So here is an example of how the architecture looks. So you have a single database, and you have multiple sets of tables which represent logical namespaces, and then each tenant resides on one of the namespace, which is the schema. So this is how tenant onboarding looks. As and when you sign up a tenant, you create a new schema, migrate all your models to that particular schema, and then one crucial thing is you have some app code to basically route your requests to the right schema based on the tenant in action. It's very similar to the database approach. What are the pros and cons with this approach? So the first is it has a better resource utilization story when compared to a one database per tenant architecture. And the reason is because finally it's a shared resources architecture. The second is, again, it's easy to start. The reason is you just create a couple of schemas, point your app to the right schema, and you're all set. And the third is, as you're having logical namespaces and each tenant belongs to only one namespace, you inherently have logical isolation. The cons with this approach are again similar, that it becomes hard to manage. For example, you wanted to add a column across all the schemas, then you may want to make sure that it's consistent across all the schemas. Second, longer running migrations, because you need to run your models across, say, hundreds or thousands of schemas. And the third, again, that performance degrades as the number of tables as the number of schemas increase, the number of tables in the underlying database increases, by which performance also deteriorates. Now let's come to the third model, And this is the primary focus of this talk, the shared table architecture. So the shared table architecture is pretty straightforward, in which you have a database and you have a single set of tables where all your tenants reside. And you would identify each tenant based on the tenant ID column which you have here. So I have a small example here. So this is an example where you can use the platform to go ahead and create your own store. So it's very similar to a Shopify. In this, you have a number of models or number of tables like stores, line items, products, and orders. And then you have the store ID column, which represents the store in action. So this is the tenant ID. So this is how you represent and depict a tenant which is in action. So what are the pros and cons of this architecture? The first is it is easy to maintain. So the consistency story is very straightforward here, because finally if you want to add a column or create an index, you go ahead and create on that particular single set of tables, and the database itself guarantees that the operation is consistent. Second is faster running migrations, because finally you have a single set of tables, it's fast, your migrations are only focused on those models. Third is it also has the best resource utilization story, because you have a single set of tables across all the resources available which the database provides. So all of these translate to faster performance. This is what we have seen, that as your number of tenants increases from say thousands to hundreds of thousands, you see better performance, better scalability with this approach. But then one con with this approach is the isolation story. So you need to have your application code to explicitly handle isolation. You need to make sure that all the ORM calls are always scoped to a single tenant. So this is one important thing which you need to take into consideration with the shared table architecture. So I have a summary slide here which talks about all the architecture. So you have one database per tenant, you tend to start quickly, you get isolation guarantees, but you have bad resource utilization and it's not that scalable. The second is one schema per tenant. You have better resource utilization compared to the one database per tenant, and it also provides logical isolation, but then it's not that scalable. And then the third is shared table architecture. And this approach is the most scalable. It scales to over say 100,000 tenants, but the problem is you need to explicitly make your app code handle isolation. So that is one very important thing which this model requires. So considering that we are going forward with the third approach, which is the most scalable approach, a small tip which I want to again stress is in the shared table architecture, it is important to make sure that all ORM calls are scoped to a single tenant. So this is where the Django multi-tenant library comes in, and it automates all the ORM calls to be scoped to a single tenant in the shared table architecture, where you represent the tenant using the tenant ID column. So this is what the Django multi-tenant library looks. And here is a quick summary of what it does. So today, without the Django multi-tenant library, you'd have your API calls doing something like this. So I want to get the suitable purchase for the ID 1. And then that would translate to a SQL query, say select star from purchase, where ID is equal to 1. But then once you start using the Django multi-tenant library, that particular API call would automatically have the filter added. So you'd have the store ID filter there, as you see there, that's the tenant ID, and it automates adding that filter to the SQL query which it generates. So let's get into specifics on what are the components which make this magic happen. So the first is something called as a tenant model. So the library introduces something called as a tenant model, which you need to inherit all your models with. We'll get into details on what that actually does. Next, you change all your foreign keys to tenant foreign keys. And tenant foreign keys, again, a class which the Django multi-tenant library introduces. And the third thing is you need to make sure that you set the tenant, so via an API call. So the library gives you a simple API called setCurrentTenant, through which you can set the tenant for which the API calls needs to be scoped. So now let's get into details on what each means, right? So the first is, what is a tenant model? So tenant model defines a new manager So the Django ORM framework has something called as a manager. That's where all the APIs flow from. So whenever you do an API call in Django, it goes via the manager, and then like it does the query. So what TenantModel does is it defines a new tenant manager in which you inject the suitable tenant. So if you see there, the tenant is injected, by which all the API calls for a particular model are always scoped to a tenant. This is for a single model. The second is Tenant ForeignKey. So Tenant ForeignKey mimics composite foreign key behavior. So what this does is it basically scopes all the reference model lookups to a particular tenant. A simple example is you're getting the name of the product for which a purchase is associated. So that particular API call is again scoped to a tenant. So you'd have a tenant ID filter to the product model there. It also handles select related and prefetch related, which the Django ORM provides. So those also would have the tenant ID filter automatically added. It also handles the case of explicit joins, where you have product underscore name or something like that. So the underscore concept introduces explicit joins. So you would have filters also for that case of explicit joins. The third is set current tenant, and this specifies which tenant the API should be scoped to. And then there are two options. One is you have this set at the authentication logic via middleware. So this is at the top of your application, and all the API calls below the authentication are automatically scoped to a tenant. Or you can set it explicitly at the top of a function, for example, a view or an external task or a job. So now let's get into how actual code looks in a real-time production environment. So without the Django multi-tenant, your models would look something like this. So you'd have like models.model or like models.ForeignKey, right? But then once you start using the Django multi-tenant library, you change the construct to something called as TenantModel and the foreign keys to Tenant ForeignKey. So this is the first step where you introduce TenantModel and Tenant ForeignKey to your models. The second is you write a middleware which injects a tenant at the authentication layer itself, so that all your API calls following that are automatically scoped to a tenant. So if you see the last one, you have the set current tenant with the current tenant. So once these two steps are done, now you have a scalable architecture to build a multi-tenant app, and you have isolation guarantees that all your API calls are always scoped to a tenant. So it's just these two steps and you're done. So what are the benefits of the Django multi-tenant library? First is it is a drop-in implementation of the shared tables architecture, so it automates a lot of stuff for you. Next, it guarantees isolation. And last but not the least, it lends itself cleanly to with a distributed Postgres architecture using Citus. And this would be the last part of the presentation, where I'll talk some about what Citus does. So this is the Django multi-tenant library. It's all open source, and feel free to go ahead and check out, and also feel free to lend a star. So in the next part, I'll talk about how do you build infinitely scalable multi-tenant applications with Citus. So with whatever we discussed now, you have Django multi-tenant with Postgres. But then like your data is growing, say like it's hundreds of gigabytes, and then it's growing to like say close to terabytes, and you're running into performance bottlenecks because finally Postgres is a single node database. At that stage, you might be thinking of like probably distributing Postgres or like say manual sharding or something like that. That's where Citus is useful. So Citus is a product which lets you horizontally scale Postgres. So the idea is you can shard partition your data across multiple Postgres databases, but for the end user, it looks and feels like a single node Postgres database. So that's what it does. And if you get into the architecture, so this is how it would look. So you would have something called as a coordinator node, and you would have something called as worker nodes. So the coordinator node is the node which your application connects to. That's where like you run your APIs, or like say you run your migrations, etc. And the worker nodes are the nodes where the actual data exists. That's where the actual computation happens. So what you do is you'd basically, in the shared table architecture, you'd say that, okay, let me shard all these tables, or let me partition all these tables on the tenant ID. So in this example, I have company ID as like the tenant ID. So there is a simple API which Citus provides. So once you do that, what Citus makes sure is that all the data related to a single tenant goes and resides on a single worker. So as and when you run like a query related to a particular tenant, the query is routed to the right worker and it gets executed. Along with this, the biggest benefit you get is you can keep adding smaller nodes to your cluster and rebalance your data all in an online way. So you don't need to take any downtime with respect to reads and writes. So that's where the horizontal scalability thing comes in. So we have customers with like probably like 80 nodes Citus cluster with close to like a petabyte of data. So this is our GitHub repo of Citus, and please feel free to go ahead and check it out. And by the way, it's an open source extension, so it is compatible with the latest Postgres version, which is Postgres 11. It just got released a couple of like weeks ago. And then also feel free to lend a star. Awesome. So that's it from my side, and let's keep scaling out Django. Thank you.
We've got about 5 minutes for questions.
Yeah.
I'm wondering if you know of any similar libraries for SQL Alchemy. I know you love Django, but some of us using SQL Alchemy.
That's a good question. For SQL Alchemy, I think if you look at this, the crux of the of the library is the tenant ForeignKey stuff. So the reason it doesn't work drop-in in Django is because it does not have the composite ForeignKey construct. But I think SQL Alchemy already has it. So, and then I think you can define a scope in SQL Alchemy. I'm not like a SQL Alchemy pro, but then I think it already has the composite ForeignKey like idea. So I think it should be more straightforward than Django, if that makes sense.
Any other questions? We have a fair amount of time for questions.
Go ahead.
Is Citus opinionated on what kind of partition algorithm you should be using, or can you sort of select what works best for you?
Yeah. So the way Citus works is it uses the hash functions which Postgres automatically provides. So Postgres has hash functions for data types. So if it's an int or if it's a big int, there is a hash function which Postgres natively provides. And that's what we use. But then as it's an open source database and it's all like extensions, you can write your own hash function and define sharding based on that. And we have a couple of customers who do that as well. So that is possible, but it's a little more manual, I'd say so. Yep.
Any more questions?
Do you know if the kind of architecture you talked about is used by Shopify or and Salesforce?
That's a good question. And I think that Shopify uses that model. And the reason is because logically, I think so. I mean, obviously, I'm not 100% sure, but I read a blog where like they use this architecture where they represent the store ID, but then probably like we need to confirm so. Yep. And I'm not sure of Salesforce. I'm not sure. But Shopify, I think so. Yeah.
Any more questions?
Awesome. So a couple of things. So I have the Django multi-tenant library here. So feel free to like go ahead and check it out. And also I have the newsletter, Citus Data newsletter. So this has like very interesting technical blogs, and trust me, you'll enjoy it because it's all technical content. And I know the people who have worked hard to make the content delightful. So go ahead and check it out. And also I have some socks at the end. So while leaving, go ahead and collect the socks. And thanks again for attending my talk. So.